Okay, grade 12s. So what we want to do in this video, I want us to look at this part of Newton's law, which is called Newton's law of universal gravitation, right? A force of gravitational attraction exists between two particles or objects anywhere in the universe. So anything that has mass, there's a gravitational force that exists between the two objects or the particles. Okay? The magnitude of the force is directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. This part here, when they talk about the distance between their centers, this is very important. Distance between their centers, this means that you will always use the radius and not the diameter. So sometimes they will give you the diameter. Remember to divide the diameter by 2. It will give you the radius, and that is what you're going to be squaring. Okay. What is important here is the math that you would need to learn, right? Or the math that you would need to be able to do in order to actually do these sort of questions. They will not always be asking you for the force. The gravitational G is a gravitational constant, so they cannot really ask you to solve for the gravitational constant because it's a constant, it's always there. But maybe they might give you the distance in the radius, right? And then maybe of the mass of like one planet. Okay? Let me put it to you like this. Speed is equal to distance over time. Sometimes they'll give you the speed and the time and they want that distance. You must now practice making distance speed multiplied by time, and then time is distance over speed. Okay? Formula manipulation is important when it comes to this aspect of the work. Okay? Okay, now that we've learned about the law of universal gravitation, you should be able to answer an exam question in metric. Okay, this question that you see on screen was taken from November 2015. Okay, and it's pretty straightforward. You should be able to grab all 20 marks here. And yeah, just have 20 marks of your 150 mark paper in the bag, just like that. Okay, 2 blocks of mass M and 2.5 kgs respectively are connected by a light extendable string. The string runs over light frictionless pulley as shown in the diagram below. Firstly, 2.1.1 is the Newton's third law. Okay, so we know that Newton's third law. Okay, question 2.1.1. Newton's third law states that a force acting on body A Oh, okay, no. Let me do it like this. Let's say it like this. Let's say that body A acts on body B, right? Body B will exert an equal and opposite force on body A. Straightforward, right? That's straightforward. Okay, my page is a bit small, guys, so I'm going to erase every time I need more room. Okay, we can continue here. We say calculate the tension in the string. Okay, the coefficient static friction between the known mass and the surface. Okay, but wait. We need to first calculate the tension in the string. Okay, remember the diagram is stationary. Okay, diagram is stationary. So what we can say is that if it's stationary, that means the tension is dropped by our weight of 2.5. So F net, which is the tension, so all the forces that are in the string is equal to mass times acceleration, which we know is 2.5 multiplied by 9.8. Two 2.5 times 9.8, and that is equals to 24.5 newtons. So now that is the total force. That's the total force. Okay, that's the total force. Okay, question 2.1.3. Calculate the minimum value of M that will prevent the blocks from moving. Okay, so we know that the weight, we've calculated the weight, right? And that weight keeps the whole load stationary, right? So that would mean that we can say this. This means that this statement will be true if we say that the frictional force is equals to weight. Now our frictional force is equals to 24.5 newtons, right, is equal to frictional force, remember, that's equal to the coefficient of friction multiplied by mass multiplied by acceleration. Okay, mass will equal to 24.5 divided by the coefficient of friction divided by acceleration. Coefficient of friction multiplied by 9.8, and that will give us 12.5 kgs. So when mass M is 12.5 kgs, the whole system will remain stationary. Okay. Now, the block of the unknown mass M is now replaced with 5 kg. The 2.5 kg block now accelerates downwards. The coefficient of kinetic friction between the 5 kg block and the surface is 0.15. Now we need to calculate the magnitude of acceleration. Okay, we need to calculate the magnitude of acceleration now. Okay, so I want to come here. Okay, we don't use this mass. This mass is for stationary scenario, right? What we are going to do is that we now need to calculate, firstly, the frictional force of kinetic friction. Then we are going to say that F net is equal to mass times the acceleration. F net will be all of the forces that are in the system, right? Which will be the frictional force, the weight will equal to mass times acceleration, and then we have the 2.5 kg of weight, right, that is accelerating down. But we also need to put the weight that is being pulled down by the gravitational force, okay? And then we can equate all of that minus the frictional force of kinetic friction. Yes? Okay, but let's do it practically. Let's do it practically, right? So firstly, what we want to do, we want to write a formula down that says that F net is equals to mass times acceleration. We have two masses, right? Now, F net will equal to weight minus kinetic friction, which will equal to mass times acceleration, right? Now, first let's go to Fk. So the frictional force will equal to the coefficient of friction. Okay, I want to write that symbol. The coefficient of kinetic friction. So it's going to be equal to the coefficient of kinetic friction multiplied by weight. Now, what is our weight? Let's go back to the question. What is our weight here? Okay, they've replaced it with 5 kg. 5 kgs. Okay, so now we need the weight. So we're going to say that 0.15 is equals to 5 times 9.8, right? So the frictional force is going to be 5 times 9.8 times 0.15, which will give us 7.35 newtons. Okay, remember we still have this formula here. Okay, but F net must also consider the 2.5 kg It is already there, that is being pulled down by gravity, right? So that means the weight of the whole system is being pulled down by the 2.5 kg block, and it's being pulled down by gravity, right? So 2.5 multiplied by 9,8, we know that it's 24.5 newtons, right? Now, we know that the block that is moving is this 2.5 kg block. Now we want to know how fast it's moving, how fast it's accelerating. So we come back here, we write this formula that the weight minus the force of kinetic friction is equals to mass times acceleration, right? That means that 24.5 minus 7.35 is equals to 2.5 a. And then the acceleration, you'll say 24.5 minus 7.35 equals 17.15. That 17.15 is divided by 2.5 kg of mass. You'll find that the block is accelerating at 6.86 meters per second squared. Okay. Okay. That's some great stuff right there. Really brilliant. Everything just coming together. Okay. I want to move here to here. Oh. Oh, okay. Move to that. There we go. Okay. Let's move over to the last question. A small hypothetical planet X has a mass of 6.5 times 10 to the 20 kgs and a radius of 550 kilometers. Okay. Calculate the gravitational force that planet X exerts on a 90 kg rock. Okay. So this was part of our first lesson, remember? So what they want here is they want the force that the two objects are exerting on each other. Okay. Okay. We know that the force is equal to gravitational constant multiplied by mass times mass over the radius squared. So G, gravitational constant, you don't need to memorize this. It's in your formula sheet, right? It's 6.67 times 10 to the negative 11. So 6 bracket 6.67 times 10 to the negative 11 multiplied by the first mass. He gave us the first mass. The first mass is 6.5 times 10 to the 20 and 90 kgs. Okay, 6.5. So it's 6.5 times 10 to 20 multiplied by 90, right? And then remember, distance is in meters, so you need to 550 times 10 to the 3, add the 3 zeros, and that's all squared. Right? And then that will give us the fourth. So we're going to say 6.67 times 10 to the negative 11 in brackets. All of that is in 6.5 times 10 to the 20 multiplied by 90, and all of that is 550 times 10 to the 3 to make it into meters, and all of that is squared, all of that in a bracket, and then we have the answer of 12.90 newtons. And that is your answer. Okay. Please let me know if there's anywhere I did not explain properly in the comment section, and then I'll be